Hello and welcome back to a new chapter. I'm glad you made it until here, and I hope you enjoyed the courses so far. If you feel like something is missing and there are topics that I didn't cover but I should, or any helpful tip is appreciated. So in this chapter we will focus on inductors, and we will try to demystify this popular passive component, and of course, as usual, we will build circuits with it. In this course, we will try to answer some questions like what is an inductor, what does an inductor do, and last but not least, how does an inductor work? So without further ado, let's begin. Let's start by looking at the difference between the current waveform between the two circuits. In both circuits we can find a simple 5V DC power supply, along with a switch, a resistor, and the difference is that here we don't have an inductor, and here we have. And by the way, this is a schematic symbol of an inductor, okay? Now first, let's examine how the current looks like within the first circuit. So if I close the switch, you can notice that the current instantly rose to 50 milliamps. But why 50 milliamps? Because the current is defined by the voltage of the battery and the value of the resistor. So 5 volts divided by 100 which is the equation of Ohm's law, we get a current of 50 milliamps. Alright, nothing fancy here, let's move on to the next circuit. Let's see what this graph will show to us. Let's close the switch and look here. What is happening here? Well, the current didn't instantly rise to 50 milliamps, it needed some time until it reached the peak value of again 50 milliamps. Well, 49, but it's the same. So what can we deduce from this graph? Well, we can deduce that the inductor is opposing the sudden change of current, so it cannot keep up with the sudden change of current, and we can even say that its initial resistance is high at the beginning, but as the time passes, its resistance is decreasing to 0. And why is it decreasing to 0? Because if the inductor would have any resistance different than 0, the current wouldn't be 50 milliamps, but less, right? We would have two resistances, and more resistance means less current. But no, the current is the same as here, so this is a clear indication that after a certain time, the resistance of the inductor drops to 0. We will have a dedicated chapter where you will find out that the resistance of an inductor is not called as resistance, because only resistors have resistances. And this type of resistance is called as impedance, which also tries to oppose the current flow. But it's a bit more complicated, not very much, but you will see that impedance is actually influenced very much by the frequency of the signal passing through it. And not only inductors have impedances, but capacitors too. Anyway, with these informations, let's go back to the PowerPoint. The first question we should answer to is, what is an inductor? Just like resistors that has resistances, inductors have inductance. Inductance is a key parameter in electrical and electronic circuits. Like resistance and capacitance, it is a basic electrical measurement that affects all circuits to some degree. So an inductor is a passive electronic component which is capable of storing electrical energy in the form of magnetic energy. So basically, it uses a conductor that is wound into a coil, and when electricity flows into the coil from the left to the right, this will generate a magnetic field in the clockwise direction. When voltage is applied across a coil, the voltage causes current to flow through the coil. Remember, current always requires voltage, and voltage always results in a current when applied across a conductor. So the current flowing through the coil creates a magnetic field around the coil. Less current means weaker magnetic field, higher current creates a higher magnetic field. Inductors have inductance, and for example the inductance of this inductor is 1 Henry. The point here is that inductance is the ability of an inductor to store energy, and it does this in the magnetic field that is created by the flow of electrical current. So energy is required to set up the magnetic field, and this energy needs to be released when the field fails. And the question is, how can we release the energy that this component is storing right now? Exactly, just interrupt the power supply, and the magnetic field that built up around the coil will collapse, creating a current that will flow in the opposite direction. And this current will flow until all the energy is released. Nice, right? So an inductor is just a coil of wire around some kind of core. The core could be just air or it could be a magnet. When you apply a current through the inductor, a magnetic field is created around it, and by using a magnetic core like here, the magnetic field will be much stronger. So the inductor is similar to the opposite of a capacitor. In series, it will resist alternating current and let direct current to flow free. It's like a bully component. It will mess with the alternating current, but the direct current he will let be. So don't try to mess with the inductor by being alternating. It will beat you down. So here are three circuits which are identical except for the size of the inductors in them. A larger inductor, which has higher inductance, has more opposition to changes in current. The inductor on the top is the largest, so the current flow is smallest in that circuit. And the AC source is constantly trying to change the current, and the large inductor is best at opposing those changes. And this brings us to the next question, which is, how does an inductor work? You have to know that a current through any wire will create a magnetic field. If you are an Arduino fan, you have probably seen this type of cables. The point here is that almost all the cables you see, their conductor inside is made out of copper, and when a current passes through them, a magnetic field around the copper wire will be generated. The inductor is also a copper wire, but it's shaped so that the magnetic field will be much stronger. Which inductor between these two you think that will have a stronger magnetic field? Assuming the number of turns are identical for both of them, the space between the turns is the same, and the current passing through them is the same, which one will create a stronger magnetic field? Yeah, exactly, this one, because it has a magnetic core which increases greatly the magnetic field, while this one doesn't have a magnetic core. Again, the core could be just air or it could be a magnet. The reason why inductors doesn't allow AC current to pass through is because of this magnetic field. Well, this field does some magic physics stuff that resists alternating currents. And if you're curious to find out what, then don't worry because you will find out what in the next courses.